So an 8-gram bullet is suddenly shot into a 4-kilogram block that is at rest on a frictionless horizontal surface. As shown in the figure, the bullet remains lodged in the block. The block then moves against the spring constant and compresses it by 0.3 centimeters. The force constant, spring constant of the spring is 250 Newton per meters. What is the initial speed via the bullet? Okay. Okay, so do you want to like just go over it or like try to? Okay.
If we could go over it.
Okay. Yeah, that sounds good. You good with this, Zach?
I put in what I got.
Oh, really? 60 seems kind of big.
Yeah. But then it gets multiplied by. I'll edit it again.
Okay. Make sure that because it should be 4.4 times 10 to the negative third, right?
There.
Because divided by 1,000. Something
I
better.
can figure out what I did wrong.
Okay, cool.
Thanks, man.
Yeah, did it work out?
That board's been written on so many times.
Yeah, you can see.
Not clean.
Yeah, they haven't cleaned it.
They forget about just remove the back.
I don't know, something. It's crazy. Like it's clean like here,
Yeah.
just in this middle. Okay, so let's see. What do we have?
So we have an 8-gram bullet.
Okay, so I'm gonna use just a little m for the bullet, so 8 grams, right?
Yeah.
So that's gonna be.
0.08. 0.008.
Yeah, 0.008. Okay, so then let's
Then
see.
we have
Mass of the block, right?
Mass of the block is 4 grams. 4 kilograms, sorry.
Okay,
0.04 kilograms.
sweet.
And then it's at rest on a frictionless horizontal surface as shown in the figure. The bullet remains lodged in the block. The block then moves against a spring and compresses it by 3.7 centimeters.
Okay, so we have change in x is 3.7 centimeters.
Yeah.
It's gonna be 0.037 meters, and did it tell us anything else? It's still a spring constant, right?
Yeah. The force constant of the spring is 2,500
Newtons per
Newtons per
meter.
meter.
Okay, cool. And it wants to know what is the speed of the bullet.
Yeah, the speed of the bullet.
That's what we're looking for right there. Okay, so this one, you kind of want to work backwards. So start from this situation and then go to there, like solve so you can get to here.
Okay.
So when this bullet is like shot in and then the spring gets compressed with the block, what can you tell me about this situation, like right here? So like what kind of energy does this thing have?
Well, when it's shot into the block, there's kinetic energy when it's
Yeah. It's kinetic energy, right? So
Yeah.
what about when it's fully compressed and this thing's like stopped right there?
When it's stopped, it's just the potential energy.
Right, it's just potential, yeah. Okay, so right here at the final position, because initially it's shooting and the final position, it's totally compressed, right?
Yeah.
So it's all potential energy. So we're going to use like potential energy with spring, which is going to be 1/2 the spring constant times like the change in distance squared. Okay. And that's going to be the total energy of this whole thing. So I would solve for that first.
Yes. 46.25.
Okay.
Oh wait, never mind. I didn't square.
Oh, square this?
Yeah.
Yeah, so make sure you
0.5
square that.
times 2,500 times the 0.037 squared.
Yep.
So 1.71.
Okay. That's pretty small.
That seems small.
Yeah.
That's right, though.
Let's see. 0.7 squared. Yeah, it looks right. Can I see something real quick? I just want to see the squared in here, see if that makes sense. Yeah, no. Okay, yeah, that's fine then.
Okay.
That's what it is. Okay, so 1.7 joules is the total energy of this thing here, right?
Yeah.
Okay, so if this, so this is like the total energy. Okay, so now we can use that energy that we found here to solve for the kinetic energy right before it hit, right?
Okay.
Because before the block hit, before this block and bullet combo hit, it had all potential energy,
Mhm.
right? Because the block was sitting here, hit, all kinetic converted into potential.
Yeah.
So we're gonna set it up like, so this potential energy equals kinetic energy, right? Which equals 1/2 mv squared.
Yeah.
So our kinetic energy is 1.71 joules. 1/2. Well, the mass is the mass of the block. Plus, so is the block plus the bullet, which doesn't really make a huge difference, but. And then we're trying to solve for the velocity of the bullet block combination.
Okay, so we're solving for this V. This V.
Yeah. Mm-hmm. Yep.
Yeah. All right. And then that should give me the velocity of the bullet.
Yeah.
Okay.
Yep. This should be the velocity of the bullet. Let's see. Yeah. Whoa, no, sorry. That shouldn't give you the velocity of the bullet. That's just the velocity of the bullet and block.
Oh, okay.
Yeah,
Okay.
sorry.
No,
I
that's
was
fine.
like thinking for a second about something. So, yeah, so we just want to find this V squared. Yeah, and then we still want to find the velocity of the bullet though.
So I got 0.92 meters per second.
Okay.
So
That's like that's the velocity of the bullet and the block before it hits, right?
yeah.
Okay, so we want just the velocity of the bullet.
Yeah.
So we're gonna set it up like a momentum problem now.
Okay.
So here's our initial situation: bullet, block. So this thing has velocity 0, right? And then our final was this together, and they're moving at 0.92 meters per second, right? So this is initial. This is like final.
Okay.
So we're gonna set up like.
Do we just use this formula now?
Yeah, except there's no 1/2. It's just. See, this is for like kinetic energy,
Uh-huh.
but it should, since the equation for momentum is just mv, mass times velocity.
Oh.
We don't have to worry about the 1/2 for the squared.
Oh, okay.
Yeah. So we're just gonna take our initial velocity. So like bullet plus. Well, the block has 0, right? Momentum.
Yeah.
So it's just 0. And then finally, you'll notice they're together, so it's an inelastic equation,
Uh-huh.
or momentum. So we're going to use the mass of the block plus mass of the bullet times the velocity that we got here.
Okay.
So we're just going to try to solve for this now. So mass of the bullet was 0.008 kilograms
Uh-huh.
times velocity of the bullet, that's what we're looking for. So then we have our mass of the block plus the bullet times this new velocity
Okay.
of like the whole thing afterwards. And then we just solve for the bullet.
Okay.
Yep.
Okay.
Yeah. And that should get you what you're looking for.
So, the 0 would be the mass of the block times the velocity of the block, and that's why it's 0 because it's at
Yep.
rest.
Yep.
Okay.
Yeah. So that's like 4 times 0.
Yeah.
So yeah, you don't have to worry about that
I
really.
just have to write it out algebraically, so like the formula.
Oh yeah. Yeah, this is like what it looks like
Yeah.
before. You could rearrange, really, it's really simple. Basically, just take that, divide it by, right? So you just have velocities, all that.